The quad's still running in the
All
background.
right,
Doesn't matter.
we're good.
Good. It's ready?
Yeah,
Hey guys, I'm Nayab.
I'm Severin.
And this is Sean.
We made Health Grid Futures. It's a GPU accelerated multi-agent pandemic, which is simulated and powered by NVIDIA Grace Hopper.
So basically, how the system works is it's pretty simple. We meant to make the UX pretty friendly for anyone to use, not just researchers. But you define your system here, so you can take a map of something actually in the real world. So here's SF Metro, and then you can define the complexity here, how many zones you want to split up whatever your city is into, and you can even do a more detailed graph and edit the individual zones yourself, the population and everything. Then what you do is interventions, the AI agents decide interventions actually themselves individually. This is just to see sort of what you can get for examples. And then you can define your scenario here, how long you want the sort of event to last, 28 days, the initial number of cases, all this stuff. And then you can launch the simulation. And after the simulation runs, you get your result for like how many cases there will be for a naive simulation where you get a baseline and a naive where you just do baseline is naive is like no interventions at all, just like let it run. And then recommended is like what you actually get if you follow the agent's recommendations for what interventions to do. And so then you can see sort of like the impact here, how many cases you avoided. And then these are some of the blue and red team scenarios for what they recommended. Red team is working against you. So this is going to be like, reductions in healthcare capacity or viral mutations. Blue team is on your side. So proposals of policy or lockdowns, all of that. And then here's our Pareto frontier for where everything converged to, all of our simulation branches. And then this is our tree. We didn't have much time, so we couldn't get a full tree working. But yeah, this is proof of concept.
And the reason why it works better on the Spark GGX is because when it works locally, we can, instead of focusing on one CPU, we could run many branches and many different simulations to kind of do mutation-based understanding so that we pick the best model, we pick the best simulation of deaths, economic costs, how it spreads in diseases. So that's why it's specifically working on the Spark. We could run all those simulations, we can go through all the research papers and make sure all the data is simulated and then we can compare it with each other. And we end up with the graph that has all the results, all the cases, hospitalization, utilization, and economic disruption. Because with all of that, we using a device, we end up with all the correct data.
Thank you.